One of the lines of research of this department is into the study of sustainable construction material, cement in particular, which is a very unique material. It's a material which, first of all, is the one which is produced with the largest volumes, with about 4 to 5 billions of tons produced each year. And this material is absolutely necessary to sustain the demographic growth, but also the growth in terms of urbanization and the infrastructural growth. This research has strong links with the Sustainable Development Goals, because we want to aim at having sustainable communities and cities, so built using sustainable and low CO2 construction materials. Cement production also poses some environmental problems. So first of all, the processing of the raw materials releases CO2 in the atmosphere. So cement is a big CO2 emitter, and it is estimated that approximately 5 to 10% of the total anthropogenic CO2 emissions are associated with cement production. Then, of course, cement also consumes a large amount of raw materials, and again it is estimated that approximately 40% of the nearly 100 billion tons of raw material extracted each year feed into the construction sector. Over the last few years, we have established several collaborations with institutions based in the African continent. So why Africa? Basically because this continent has the highest rate of urbanization in the world. So we believe that it will represent the future of construction. So we are experimenting with raw materials that are readily available in this continent to try and design some more sustainable formulation that have the potential of replacing the standard Portland cement. So, for example, by blending Portland cement with locally available clay materials like laterites, we can obtain less impacting material in terms of CO2 emission. Okay, so if this is a standard Portland cement, this is a sample of cement blended with 30% of laterite soil. It's a soil rich in iron oxide, which conveys this red color. So also in terms of aesthetics, this kind of material can also have links with vernacular architecture. Among this collaboration, recently we also got started with mobility program funded by the Erasmus scheme, which envisages the exchange of both student and teacher with the Meru University of Science and Technology based in Kenya.
My name is Victor Mutai. I come from Meru University of Science and Technology in Kenya, and I am privileged to be here in University of Padova through Erasmus Mundus exchange program, and I am grateful to be part of this program because it has enabled me to be here do my research, especially with my master thesis, and particularly I do research on cement as a construction material. And given the fact that the biggest challenge in Africa is lack of physical infrastructure, cement is going to be a big thing that is needed in huge consumption, particularly in Africa. And looking at the Sustainable Development Goals, number 13, where we need to combat climate change and its impacts, we need to reduce the amount of CO2 by about 45% by the year 2030, and reach even net carbon zero by the year 2050, and therefore it means that cement needs to be a key factor in all this. So my research is geared towards having blended cements, whereby we reduce the clinker fraction in the cement and using alternative raw materials locally available. So particularly I'm using locally available material in Africa called canker fines, and I'm incorporating to cement so we can lower the clinker fraction from 95% that is used today to between 40 and 50%, and that will see the production of cement and really lower the CO2 emissions. So that is what my project is about here, and I am glad to be here because this place has enabled me to really do my things and everything here under the guidance of Professor Valentini, and it's really been great. We have had this wonderful time and chat and discussions, and it's really been great. Yes. I think going forward, the Erasmus Mundus program is really going to be impactful, especially to us in Africa, because it really gives us an opportunity to experience research, especially in the developed country, whereby we really have state-of-the-art facilities. I'm happy to be here in University of Padova. One department, everything is there, and it's really great. It's really great.
My name is Christelle Mobosiambiwa, a PhD student from the University of Yaoundé in Cameroon. And I'm very happy to be at the Department of Geosciences, University of Padova in Italy. I've learned a lot throughout this process coming to Italy. And my research topic is using laterite in producing alternative cement, which in particular we work on acid-activated cement using phosphoric acid. As we all know, cement is taking another turn in the world, and being in Cameroon, we have this laterite which is very abundant, and it's not really being used for construction purposes. It's just being utilized to dam roads and maybe to just use it to build small houses and everything. So the question was, if we could use this material in producing more durable cement, what was going to be the outcome? Especially that this material is very rich in iron, like almost 46% rich in iron oxide. So that was the purpose of our research throughout this period at the University of Padova, where we tried to understand the reaction kinetics. We wanted to understand what was happening in this material when mixed with phosphoric acid. So we tried varying the chemical, we tried using materials with different chemical composition, and we also varied the molar concentration of the phosphoric acid. And somehow we could also see that the iron present in this material participated in the reaction, which is not always seen with that of the alkaline activated material. So this is just a new act. Still much has to be done using laterite and phosphoric acid, but somehow we have the notion of how this material behaves with phosphoric acid, and the properties turns out to be very good, and we have somehow of a ceramic type of material. Another thing I was introduced to at the course of my study at the University of Padova by my supervisor, Professor Luca Valentini, was the notion of blended cement. It's somehow funny because I didn't have this notion before, and I find it more challenging and more fun to be with because it's a context for Africa. It is more real for Africa, and it is more applicable for Africa. As earlier said, we have this raw material, laterite, which is abundant in nature, and it's not being used. And somehow, cement is very expensive in Cameroon. So trying to reduce the CO2 emission and trying to produce a cement for a cheaper cost where even a local, the least privileged person can buy, the option of blending laterite, producing LC3, producing blended cement is going to be a good option. So I would like to say for this last month, what I've learned on blended cement is really a new plus to my CV. I can say my stay at the University of Padova at the department was one of the best moments of my life.